Hi, welcome back to our another junior statistics video and our very last junior statistics video. This video is all about misleading statistical graphs. There are many ways people try and mislead you in statistics to try and make you think something's happening when it's not. Donald Trump probably famously has quoted and started using this term fake news. So we're going to go through, I think, 3 examples just to show you some of the things people do to try and mislead you and fool you into thinking things. So let's start off with our first example. This is a bar graph, and here's a quote from this graph. Lilyville College claims a huge jump in NCEA pass rates in 5 years. So what we've got, the graph is a bar graph. We've got 2012 data in red on the left, and we've got 2017 data on the right in blue. And it's about the pass rates, the percentage of students who passed NCEA. Now you can see in 2012, 62% of students at that college passed NCEA. 5 years later, 67% of students passed NCEA. Now they're claiming a huge jump. And if you look at the graph, it does look quite huge. But they've done a very clever thing. They haven't started the axis at 0. They've started it at 60. Therefore, the scale is quite distorted. If I was to redraw that graph correctly, starting the scale perhaps at 0, where I probably should if it's a percentage, you can see that although the pass rates have improved from 62 to 67, I wouldn't classify it as a huge jump. All right, here's example 2. Sales are steadily increasing. Well, based on this graph, they've used pictures to demonstrate the graph. Some people do. Based on this graph, I probably would agree with the comment, bag sales are steadily increasing. But there's a lot of things that are misleading about this graph. First and foremost, are we taking the data as from the top of the bag? Or are we taking the data sort of maybe from the middle of somewhere down here perhaps? I'm not really 100% sure where I'm reading the data from. Second of all, there's no label on here. What kind of numbers do these represent? Are they in millions? Are they just dollars? I'm not really sure what they represent. And third and foremost, this is something they often do. They make it, as the bags get taller, they make the bags get wider as well. And that fools a lot of people. The moment you see a taller bag that's wider, you think it is a huge amount. It does look like 2015 sales are huge, really, when it's not really, it's just a steady increase. If I was to draw that properly, I would have a label on the y-axis, and I would have a line graph like this. It's called a time series graph, actually. And I would just draw dots at the correct data point and lines in between, and that clearly shows you it is steadily increasing. All right, here's example 3, a good old classic 3D graph. The problem with this, it's a bar graph all to do with the number of pets in a certain class, right? Frequency is how many. Problem with 3D graphs is it's very hard to read off the labels. Right, am I reading this cat at the front here, or am I reading the cat at the back? I'm not quite sure if it's just below 40 or above. No, is it above 40? I'm all confused. What about the dog? Is it below 50 or is it above 50? It's really confusing because of the 3D distortness. All right, hamster's confusing. What about lizard? Is that 0? If it is 0, why the heck did I put it? Really, really confusing. I should not be using 3-dimensional graphs when I draw these things. I should be doing 2-dimensional. Look at that cat. Cat is actually on 40 or just above 40, but in the graph above it doesn't look like it's got to 40. All right, so there's a couple of key things about graphs and the misleading nature people try and do. So thanks very much for tuning in, and all the best for any assessments.